All right, guys, we're going to finish up these notes here on solving systems by graphing, and then we're going to learn how to use our graphing calculators to find the intersection of a system of linear equations, which I think you're really going to like. So if you're rocking a scientific calculator, you can still do this by hand. Hopefully it will motivate you to go out and get the graphing calculator we recommend you have. So some of you guys, depending on which class you were in, may have got started on this problem, this example with f of x and h of x, but we'll just start fresh on it. So what we should remember always is that f of x and h of x both say y. So if you need to rewrite the function notation using the variable y, go ahead and do that if that's going to help you work with our equation. So we should recognize that f of x is written in slope-intercept form, right? Y equals mx plus b, and we should see that the slope is -2/1, and our ordered pair is 0, 5, right? So that gives us f of x, and then I'm going to use a different color here for h of x. H of x we can see is also in slope-intercept form. M is equal to 1/1, and we can see our y-intercept is 0, -1. So far, absolutely nothing has changed from what we did back in Unit 3, except that we have to do it for 2 equations rather than just 1 equation. So let's now come to over here to our coordinate plane, and let's graph our y-intercept. We go down to and right one, up to and left one, right? And I could draw my line at this point, but I'm going to hold off just 1 second, and I'm going to graph the 3 points for h of x here. So I start at 0, -1, I go up 1 and right 1, down 1 and left 1. All right, so here's the deal. Once we had our 3 points graphed, we didn't really care about the accuracy of the rest of our line. Now that we're trying to find a precise point of intersection, the accuracy of the rest of our line really matters. So what you're going to need to do, if you're not using a graphing calculator, is to extend the slope as long as is needed on both lines to find a point of intersection. So if I were to take f of x and keep going down 2 and right 1, down 2 and right 1, down 2 and right 1, you can see clearly I've gone past where this is going to intersect. And if I take h of x and I keep going up 1, right 1, up 1, right 1, up 1, right 1, we can see that right here we have a point of intersection. So we can see that my line for h of x and my line for f of x intersect at the ordered pair. Let's do it in red here. 2, 1 is our point of intersection. This is the ordered pair, which will make both of these equations true. If you plug 2 in for x and 1 in for f of x or h of x for y, the equation will be true. This is the only point in all of the infinite number of ordered pairs in this coordinate plane that will make this equation true. All right, so you can see we can do this by hand, just like we did. We did make most of the examples work out so that the coordinates are integers. So as long as you extend the slope properly and take your time and that you're precise with that, you'll be able to find your solution. If it does come down to a decimal, we would be expecting you to use a graphing calculator to be accurate. Now, here's the deal. We only have one type of solution that we've looked at here, and that is where our lines actually intersect each other one time. All right, so in the example above, we demonstrated one type of solution set. If they intersect one time, that means there is going to be one solution. But there are a couple other possible options when it comes to what 2 lines graphed in the same coordinate can do. And for this, we need to understand the relationships, right, linear equations can have. So we've already seen the first one is that there can be a single intersection. Right, single intersection is exactly what we just saw. We have 2 lines here, one going this way, another going this way, and they will intersect once and only once, right? Now, we also, you're probably familiar with this, could have lines that are parallel, right? Parallel lines are lines that have the same exact slope, but a different y-intercept, and you can see that these are going to intersect never. That's part of the definition. So we are going to have 0 intersections here. There will be no intersections between these lines. The third option is something we call coinciding lines. Coinciding lines are literally 2 lines that share every single ordered pair as a point of intersection. Now I used the blue line as dashed there just so we could see both the blue and the purple line. So there's not one intersection, there's not no intersections, there are an infinite number of intersections here. So these are the 3 different relationships that 2 lines on the same coordinate plane can have with each other. We could have a single intersection where we have 1 intersection. We could have a parallel lines where we have 0 intersections, or we could have coinciding lines where we have an infinite number of intersections. So if we take what we understand here about these 3 different relationships and what we said up here about what a solution is, we can talk about our 3 different types of solutions. All right, so pretty much we've talked about them here. We've said it before. There can be one solution. All right, there can be one solution when the lines intersect once. So if we graph our 2 lines and the lines intersect once, there will be one solution. We can have no solutions, and that would be when our lines are, well, how about I actually write the word here, when the lines are parallel, never intersect, and we can have, come on, change color for me here, and we can have an infinite number of solutions, and that is when our lines are coinciding. Are coinciding, not how you spell coinciding, let's try that in coinciding, meaning there are an infinite number of intersections. All right, so every system that we solve by graphing, and actually you'll see when we start solving using our algebraic methods, every system, the solutions will fall into one of these 3 categories. You will either have one solution, one ordered pair, you'll have no solutions, no ordered pairs, or you'll have an infinite number of solutions, an infinite number of ordered pairs. All right, so let's look at an example here in the notes. So let's take a look at f of x and g of x here in number 1. So again, going back to what we did in the example, this is slope-intercept form, right? So my m is 2 over 1, my ordered pair is 0, negative 3. Down here, this is also slope-intercept form, and so I graph there. So now I can graph these. I go to 0, negative 3. I can go up 2 and right 1, down 2 and left 1. Let's graph my other one here at 0, 2. I'm going to go down 1 and right 2, up 1 and left 2. And you can see the nice thing about this is we set up the problem so that you kind of get a point of intersection. You can see very clear if I go up 2 and right 1, I will hit that point of intersection. So I've found a single intersection. There is one solution, and that solution is the ordered pair 2, 1. All right, so that's what I would expect you to give me and show me in that situation there. So let's take a look at number 2. The number 2, I'll admit it, we're trying to trick you a little bit with that fraction. 4 over 2 is not a simplified slope. If we simplify 4 over 2, that simplifies to 2. All right, so that means f of x has a slope of 2 and a y-intercept of 0, 5, and g of x has a slope of 2 and a y-intercept of 0, 5. So if I go to 0, 5 and go up 2 and right 1, down 2 and left 1, I'm going to get this purple line. All right, let me actually change the color on this just so we can keep things easy to see here. All right, let's get off there. And if I start at 0, 2, and I go up 2 and right 1 and down 2 and left 1, you can see I am going to get the same line. Now, that dashed line doesn't mean they're not solutions. Just so we know in this situation, I'm doing it dashed so we can show that. So what I would need to see, what I would expect to see for full credit on a test or a quiz, is you need to graph the line. Need to graph the line and state that there are infinite solutions. All right, so when there's one solution, you just have to write the ordered pair. If there are infinite solutions, I do need to see the actual line that they share graphed so you can show me the infinite number of solutions here. All right, now the last one, let's look at number 4 here. Again, we're still both in slope-intercept form. There will be examples that use other forms, but we're working with ones right now that are kind of quick and easy. So my slope is 6 over 1, y-intercept 0, negative 2. Here my slope is 6 over 1, y-intercept 0, 1. So I'm going to go to 0, negative 2, up 6 and right 1, down 6 and left 1. I'm going to start at 0, 1. I'm going to go up 6, right 1, down 6 and left 1. This is probably not the best example to show you because they are so close together, but you can see that these two lines have the same slope, right? They have the same slope, but they don't start at the same point on the y-axis, which means they are going to be parallel. So these lines are parallel, which means there are no. Now let's just rewrite that. I started to write a 0. I'm not going to lie to you and pretend like I was trying to write the word no there. All right. Come on. So there are no solutions. And that would be all you would need to write there for no solutions to show me that. All right. So that's what we're working with. Your solution to your system of equations will fall into one of those 3 categories. Either one solution, all right, like here in number 1, infinite number of solutions right here in number 2 where I need to see the line graphed, and then number 4 where there are no solutions. Now here's the deal. What if you have a graphing calculator? Do you need to go through all of this work to graph things by hand to find your solutions? And you don't. The other reason a graphing calculator is going to be really nice is when our solutions are not integers. It works out really well when our ordered pair is 2, 1 or something like that. But what happens when we start having decimals? When we graph things by hand, it is impossible for us to be accurate enough and precise enough with our graphing to get accurate solutions when the coordinates are going to be decimals. So that's when a graphing calculator comes in. All right, guys, so we've got our graphing calculator here, and what we see is an important button up here in the top left. This is our y equals button. All right, this is going to allow us to input equations and functions into our calculator, and our calculator will be able to do the work of graphing the infinite number of points for the line or the curve, and then the calculator will also be able to do a lot of analysis for us of those graphs. We're going to be using this a lot throughout the rest of the year with our linear functions, with our exponential functions, with our quadratic functions, and you'll definitely be using it a lot when you get to AAT. So let's click this y equals button here, and what you're going to get is a list of y's here. You can see y equals 1 all the way through 10. So you can put 10 different equations into your calculator at the same time. Over here's the colors. If you want a cursor over, you can change the colors. So if you don't like pink, just cursor over and hit enter, and you can see you can change the color. Oops, I got an arrow. Change the color to green, to orange, to brown, to light blue. Well, let's just go with yellow. Let's just pick a random color there, and then go down to OK. And there we go. We'll use green and yellow, you know, just random colors. All right, so we've got our 2 equations here. So what we need to do now is we need to actually put the numbers from example 1. We're going to do example 1 from the notes here. So example 1 was 2, y equals 2x minus 3. Right, and notice the important thing is I use the button I use for my variable for my x is this button right here, xt theta n. Do not use the green x. That is just the letter alphabet letter x, not a variable. All right, then I'm going to go down to y2, And a couple different options here for how we put in a fraction, but the one thing we have to use is we have to use a negative symbol. This negative symbol right here, not the subtraction sign. There is a big difference in your calculator. So then what I'm going to use is the F1 function here, which I have to hit the green button and then this to get F1, and I want number 1, that n over d. And that's going to give me a nice vertical fraction bar there to write 1/2 x, and then it is plus 2. All right, so now we have put our two equations into the graphing calculator. If you do not have, your graphing calculator cannot do the vertical fraction, you can still put this in. So in Y3 here, I'm going to write the same exact equation, but I'm just going to do it with a different way of writing the fraction. So I'm still going to go negative, but now I'm going to go parenthesis 1 divided by 2, close parenthesis, x plus 2. So what you have right now in Y2 and Y3 are exactly the same equation. If you can write it vertically, I think that's nicer. It kind of keeps it more compact for you. But if you don't, you can use the parentheses with our actual division symbol, 1 divided by 2 numerator over denominator in parentheses, then x, and that will work fine. I'm going to clear this out so we don't graph the same line twice. Right, and now we need to graph this. Now, before we actually don't want to hit the graph button right away. What we want to do is we want to set the window in which we're going to view the graph. So we're going to use the zoom function for that, and what we want is right here, zoom standard. Zoom standard. So I'm going to hit 6, and what it's going to do, it's automatically going to graph my two lines in a -10 by 10 and a -10 by 10 window. So I'm on the y-axis from -10 to 10, on the x-axis from -10 to 10. This will not always be a window that shows you what you want to see in your graph, but it is normally a really good place to start looking for intersections of our systems. All right, now we can see they have a point of intersection right here, but I don't know exactly what that point is. Is that 2? Is it 2.1 on the x-axis? Is that at 1? Is it at 0.99? Is it 1.05? We're not sure, but we have this menu, this blue word calc right here. So if I hit second and I hit this button for the calculate menu, notice number 5 in that calculate menu says intersect. Our calculator can specifically find the exact ordered pair of any intersection that you have graphed. So I'm going to go down to 5, or you can just hit number 5, either way. And it's going to ask you, though, which two graphs you want to find the intersection of, because we can have up to 10. You've got to be specific about which graphs you're looking for the intersection of. So notice up here Y1, which is yellow. Some of you don't have colored calculators, but up here it'll say which is the first equation you're looking for. We want Y1, so hit enter. Then we want Y2, so that's the green one up there. Good, enter. And then just like Who Wants to Be a Millionaire from way back in the day, you guys probably never even heard of that show, but it asks you for a final answer. So you do have to hit enter a third time. I've had people get very confused because they don't understand why it's not finding the point of intersection, but so you actually still have to enter a third time, and then boom, look at that. Our intersection is 2, 1. Now we do know for sure that the coordinates are integers in our ordered pair here. So the graphing calculator, again, is really, really nice, because let's just say my intersection was not in my window 10 by 10. Well, I can hit the window button, and let's just say I wanted to go further to the right. I wanted to go further to the right, so I'm going to change the x maximum, the x-axis maximum, and let's change that to 50. And now if I hit graph, notice what's happened is I now see all the way out to 50 on the x-axis. So where we are constrained on a piece of paper by whatever the coordinate plane that's given to us on a calculator, we can extend our coordinate plane in any direction we want as far as we want, right? And as you saw with the calculate menu, we'll also be able to get decimals. So whether you want to use the calculator or not, you can still do all of the work either by hand or using the calculator. The one thing we ask is that you still show us some of the work. So let's go back to the notes and let's take a look at what we're going to expect out of you with the calculator. If you're doing the calculator, what we still expect to see on the paper. All right, guys, so we're back to the notes here, and let's take a look at what we're going to expect out of you as far as if you use the calculator, what do we still need to see on the coordinate plane? Well, if there's a single solution, what I would expect to see is the actual point of intersection, and you to still write the ordered pair down. What I also need to see is a general sketch of the lines. Now, they don't have to be perfect like they are here when we did it by hand, but the sketch of the lines you put here has to be somewhat close to the lines you see on your calculator. All right, so that's what I'm going to expect: the exact ordered, the exact point, the exact ordered pair, and a rough sketch, a general sketch of the lines. Now, if there is infinite solutions, all right, then I actually need to see a somewhat accurate drawing of the line, and you need to state that there's infinite solutions, because the only way to write down an infinite number of solutions is by graphing that line. It's not like a single solution where you can just write down one ordered pair. So I still need to see the line graphed if there are an infinite number of solutions. All right. The last thing we need to talk about is no solutions, which technically there's nothing to graph because there are no intersections on your graph. So if you just write no solutions, that's okay, but be aware, if you write no solutions and you're wrong, I can't give you any partial credit. So showing me the lines on your coordinate plane is still a good idea if you want partial credit. One more thing to talk about with your calculator. Notice when you are given something in point slope form, as we are in number 6 here, you cannot put this as it's written into your calculator because it is not y equals, it's y plus 4 equals. There is still a way you can manipulate, move things around in this equation so that you can put it in your calculator. There will be problems on the homework in point slope form and vertical and horizontal form. So we do still need to be able to graph equations by hand if we don't know how to put them into our calculator. But times that we can put them into our calculator, it obviously makes things easier and faster. So please try the homework. Please come back to class on Monday with questions, especially about how to use the calculator with point slope form, or how do we deal with standard form and things like that. Would love to talk about those. But I hope you have a great break. Enjoy time with friends and family, and take just a little bit of time to do a little bit of math before you come back. All right, guys. We'll see you on Monday.